Now moving to the other critical component, which is redo log buffer. Okay. Now let me first tell you what is redo log buffer. Again, this is the memory area. Okay. What does it hold is more important. Okay. It holds the information about the changes made to the database. For example, any user is updating some records in the database. Okay. Now what happens? I'm updating a table, updating some rows into that. Let me go back here. Okay. So again, I cannot access the data file directly, so I cannot update the record in the data file. Okay. I will update the record in the system, HGML. Okay. Okay. These updated records are kept here in the database buffer cache. Okay. At the same time, these updated records are also kept in the redo log buffer. Now, why there are two copies? Okay, when you have already installed, when you have already stored database buffer in the buffer cache, then why are you holding records in the redo? What happens? The data is returned to the data file, okay, from the redo log buffer and from the database buffer. This redo log buffer reads, writes the data. Okay, there is a background process. It writes the data from here to redo logs. There is one more background process which reads the data from here and writes into the database files. But this particular bit writes the data faster than this. In fact, the condition when redo logs is written, okay, is different than when the database buffer written. This write-up is called lazy write-up, while this write-up is called quick writer, fast writer. Okay. Now suppose you are doing some transaction. Okay. Your transactions are there and they are also in the redo log buffer. Okay. Redo log buffer have written its transaction into the database, but the database buffer cache is not yet written to the database. And for electricity outage or for some unplanned reason, this instance goes down. This instance goes down, that means the data from the buffer cache is gone. But it is there in the redo log buffer. I mean, it's not there, but it had already written its data into database. Now this data can write its data into data file. Okay, that is the reason Oracle has designed its solution in such a way that this is written to the database prior to this. Okay, and it is kept as a lazy writer. So if I summarize, the redo log buffer holds the changes which are made to the database and it is used to recover from the failure scenario. If instance goes down for unplanned reason, it is the entire instance is terminated with the help of redo entries. Okay, the data which is stored here are called redo entry. Okay, with the help of redo entries, we can recover the database. Does that make sense? Or do you want me to repeat?
So any updates or inserts gets written to the redo log buffer that gets updated immediately to the data file, right? That's what you meant to say, right?
Not immediately. Not immediately. There are 4 to 5 conditions. So that we will see when we will cover background process. But those conditions occur faster than the condition for
Okay.
database buffer cache. So for now, this data is written to data file faster, and before this database buffer cache writes its data. And the purpose of this particular segment is it helps to recover the database from the failure signal.
A
Basically,
question.
yeah.
Like if it's a electricity outage and it just like vanishes. I mean,
Mhm.
there's just no electricity, it's just all of a sudden, and then it goes back online again. Is Since the Redo log buffer is a memory, is it just empty, or will the memory recover itself?
No, it will be empty. But since it writes its data periodically, and that period is very short. Okay, let me tell you the condition here. It makes more sense to share those conditions. The redo log buffer's data is written when this is filled 1 MB. When the data is 1 MB in this segment, immediately background processes are instructed to write the data from here to data file. So even 1 MB data is also written to the database in every 3 seconds, whichever is faster. Okay. If 1 MB data is written before 3 seconds, then it will be written to database. If it is 3 seconds and data is not yet written 1 MB, for example, 500 KB data is written only in this segment. Still, in every 3 seconds, the data will be written to database. Or the moment you hit the commit, okay, you updated a table, some records are updated. In the moment you hit the commit, that means you are sure I want my data into the database. So whenever a commit is hit, commit is executed, it will start writing data into database. Or if this is filled, for example, our redo log buffer is less than 1 MB. Okay, in some cases, you may see the redo log buffer is less than 1 MB. So if this redo log buffer is one third filled, so these are the 4 conditions. Okay, when we hit commit, when the data reaches to 1 MB, okay, when this particular in every 3 seconds, and when this segment is one third used. Out of these 4 conditions, whichever occur first, it will start writing data into the database. Okay, and I have seen all the businesses can bear the loss of 3 seconds. They can bear the loss of 3 seconds.
Is the 3 second like a default setting, or can I change it, or does it make sense to change it?
No, we cannot change it because it is designed by Oracle and it is there in their code, so we cannot change, and it does not make change because if we change it to something else, then see it will change the behavior of. If we could change, then it could change the behavior of database buffer cache. It is the thumb rule that the data from redo log buffer will be written to database first, and then only database buffer cache. Now, if we were able to change its more than 3 seconds, then we could have changed the behavior of entire database. So fortunately, we cannot do this. When you will be working in your real environment, especially when you are tuning the performance, or if you are monitoring the database health or database performance, you will be dealing in these 3 segments more than any other segment.